Can you hear me now, everyone? All right, fine. Okay, right. So let's start with this. Right. I said for we'll see, right? I'm not so sure we'll need to do anything like that. Okay, so depending on the situation, depending on. Okay, just a minute. It looks like by mistake we have entered the 12th standard board. Just give me a minute. Okay, right. So let's start now. Finally, so area between VT graph and x-axis gives displacement, right? So why is this so? That's what we are going to talk about. Now, first of all, you need to understand that formula of velocity is dx by dt, right? And I hope you remember that dx can be considered to be a small or infinitesimal displacement, right? Okay, and dt can be considered to be an infinitesimal time interval, right? Dt can be considered to be infinitesimal time interval, right? This is based on what I've taught you about differentiation, right? Now, if you would take this very equation and you would write it like this, I know I have told you that actually dx by dt does not mean you are dividing two things, right? Okay, but still, in many applications, in many uses, and if you look at it one way, this is actually a ratio. This is actually a division of two things, right? Okay, so of course, if you're just going to talk about what differentiation is, then that differentiation is can be considered to be a ratio of two small changes, right? So here we are just multiplying dt on that side and we are writing dx is equal to v dt. So what this gives you again is the small displacement in a small time interval dt, right? Dx is the small displacement in the small time interval dt, right? So now let's see how would this look. Let's see how would this look on a vt graph. So let's say that here this is a VT graph, right? And this VT graph, let's say, has any shape. It doesn't matter, right? Okay, it could be any shape, right? This idea works, right? In either case, right? Some of you asked me, if you remember, that can we find this area for any shape of graph? And I said the answer is yes, right? You can actually do it for any shape, right? But the match is a little different. That's what also I'm going to teach you, right? So it could be any shape, no problem. But let's think of some small time interval dt. See, this is a small time interval dt. I hope you realize that. Actually, it is supposed to be infinitesimal. But I am sure you realize that if I draw something infinitesimal, nobody will be able to see it, right? Because that would mean that delta t tends to 0, right? It would be so small, nobody will be able to see it. So I'm just showing it here. Let's say this is that small time interval dt. And of course, this height is v, that is velocity at that time, right? So do you see here it makes something like a rectangle, right? Okay, what this is almost a rectangle. I understand that this graph is a curve. So a rectangle does not have, I repeat, a rectangle does not have a curved edge like this. But don't forget that as you make this small, the curve will appear to be like a straight line. Think about what I'm saying, right? You can see that this almost becomes a rectangle. If I draw it from here to here, this, nobody will say this is a rectangle, I'm sure, right? But if I put the 2 points very close to each other, then it looks almost like a rectangle, doesn't it? Right? And that is why we are taking infinite symbol. That if you take it infinite symbol, then you can actually make a rectangle like thing. Okay, so that makes it very easy now. So if this is a rectangle here, then the area of shaded rectangle, what do you think that would be? Look at this rectangle carefully. What do you think area of shaded rectangle is? Tell me that. Tell me, hurry up. Length into breadth any formula है. What will be its value? Look at this situation here. Look at the graph. Tell me what will be its answer. Very good. Very good. I've started to get correct answers. Well done, people. Yeah. The area of rectangle will be V dt. But like I explained just before a while, V dt is actually the small displacement. Right? Okay. Agreed? Okay, so now what we are having here is that we have found that if we take a small area which was between this graph, this is of course the graph, and the x-axis, what we have got is a small displacement. So now if you think, suppose I want to find out what's the displacement between time t1 to, let's say, t2. All right, let's say I want to find out what is the displacement. I want to find out what is delta x, that is displacement between time t1 to t2. All right, okay. So then I hope you realize this very simple idea, right? That we should, or we can actually divide this whole shape, right? You can see there is a weird shape here, right? What kind of shape? The shape is like this, right? It's a weird, is it a rectangle? Of course not. It's not a circle also. It's not a square. It's not a known shape. So what we'll do is, by taking such many small time intervals, we will divide it into thousands of such rectangles. I hope you get what I'm saying, right? We will divide it into thousands of such rectangles, right? And for every rectangle, the area will be VDT, right? For every rectangle, the area will be VDT. So what we can do is that I can find that area between the VT graph and x-axis, right, from time t1 to time t2 is actually addition of all such small rectangles. Agreed? Yes or no? Do you understand this sentence? But it's not a triangle, Vedant. Like I've said, if you will make any shape like this, I am not making it a rectangle. Nature has made it a rectangle. If you make a shape like this, then this is a rectangle. By no means this is a triangle, right? There's no way a triangle. Clear? Okay. So area between the VT graph and the x-axis from T1 to T2 is addition of all such small rectangles area. Correct? Right? See, the key thing is small or infinite symbol. If you do not take it small, this is horrible. This is totally wrong. Let me show you why. Suppose we have a graph like this, right? And you want to find the area from here to here, right? And if you don't take small intervals, if you don't take width very small, see, we took dt, if you remember, right? Very small. But instead of that, if you don't take dt, it's going to be horrible. Let's see. Suppose you take a big time interval, okay, like this. So then if you make a rectangle, do you see some area is mismatched? Then if you take one from here to here, let's say this is a bigger time interval. Now this is clearly not a rectangle, right? You can see there is once again some mismatch here, right? I hope you understand what I'm saying, right? So the bigger interval you take, the more mismatch is going to be there, right? So to avoid this mismatch, it is important that we take infinitesimal time interval, right? That's the key thing. So instead of taking such big time intervals, what I'll rather do is I'll take a very small one. So there the area mismatch is extremely small. And in fact, as you take the time interval infinitesimal, this mismatch, area mismatch will become zero and everything will become a rectangle. Here it doesn't look like a rectangle, it's a trapezium. Agreed? But if you would, if you would take the 2 points very close to each other, it would actually become a rectangle, right? That's what infinitesimal is about, right? Again, so what we are doing is we are adding all such small rectangles areas. So that addition process, works as follows. See, it's that for the first one, suppose you call it dx1, for the second one you call it dx2, for the third one you call it dx3. No, Vedant, it won't be the same, right? It won't be the same. You can, you can actually check that. We will not take trapezium because it's not a trapezium. When you take infinitesimal time interval, this thing will definitely be a rectangle. All right, it won't be a trapezium, because in infinitesimal time interval, that is 2 points very close to each other, this graph will not be able to go up or down, right? If it goes up or down, then it's a trapezium. You can clearly see that here, because from here the graph goes up, right? I hope you get what I'm saying. So it's a trapezium. But if you take 2 points very close to each other, then there's no chance for it to go up or down, right? So anyways, the first thing is infinitesimal. Very good, follow. This whole idea is based on infinitesimal, right? If you have trouble with infinitesimal, you're not going to understand, right? So I'm saying that if you want to find that total displacement, then that total displacement is like small, small displacement 1, small displacement 2, small displacement 3. What do I mean? I mean this, in this graph, right? We took so many different areas or rectangles, and now we are adding them, adding them. So finally we'll get the total area, right? Like this. I hope that makes sense to all of you, right? We'll get so many such rectangles, right? But see, if there are thousands of such rectangles, it's not possible to add, right? I'm sure all of you understand that. It's going to be so tiring, right? You'll take so much time to do that. And that is why we have a very nice thing in mathematics. To do this kind of thing, we have something called integration in mathematics. All right? This is something that people are going to study in 12th standard. All right? Okay, but we can't wait. I have to tell you that, otherwise you'll not understand physics. So I'm telling you that this process of adding such so many small things or small areas, that is actually integration. Integrate means to combine, right? Integrate means to combine or add. So don't forget that integration is actually one kind of addition. But what's the difference? But this is addition of infinitesimals, right? This is addition of infinitesimals. I'll repeat what is integration. I said that if you want to suppose find this area, then you have to divide this whole area into thousands of such tiny rectangles, right? I hope you get what I said, right? You have to divide the whole area into thousands of tiny rectangles. But if you want to add all those areas, like let's say first one has dx1, second one has dx2, third one has dx3, and so on, then adding thousands is impossible, right? It's going to take so much time. So as far as adding this is concerned, we use a mathematical technique called integration. જેમ ડિફરન્સિએશન શીખી લીધું હતું એવી રીતે હવે ઇન્ટિગ્રેશન એ શીખી લેવું પડશે, right? Okay, because it's a very important part of physics. In fact, like I repeat, I mentioned, I'm sure differentiation was thought of by Newton for the first time, right? So that he could explain what motion is. Okay, of course, follow, right? And Newton also, Newton also thought about integration for the first time once again. All right. ઓકે, તો આ બધું ફિઝિક્સ ને આ બધું મેથ્સ ન્યૂટનથી છે, એટલું તમારે યાદ રાખવું જોઈએ. એન્ડ ધીસ ઇઝ રિયલી વેરી ઇમ્પોર્ટન્ટ. એવરીથિંગ that you see around yourselves can only be explained because of all this, right? There is no other way. બાકી લોકો તો એમ કહેતા હતા motion is an illusion, યાદ હોય તો, right? Anyways, coming back to this topic here, so what is integration? Integration is, હજી તો ન્યૂટન નું કઈ આવ્યું જ નથી. Let me tell you, we still have a lot to talk about, right? So integration is a process of addition, first of all, but addition not just of anything but of infinitesimals. That is, you take very small quantities. For example, have a look at this: small displacement, small displacement, small displacement, like that. Okay, right? Small displacement, yes Divya, you're right. Small displacement, like that. So we are adding infinite symbols. That is what is integration, right? So let's have a look at what integration symbol is. Let's have a look at what its rules are, right? But before that, I hope you have understood what is happening here is that whenever you have any such VT graph, right, then you divide it into such small areas or small rectangles, then area of each rectangle is giving you VDT, right, which is nothing but small displacement or infinitesimal displacement, right? Okay, and addition of all such infinitesimal displacement is giving us total displacement, right? So ultimately this is the punchline of this whole topic. Okay, this is the punchline of this whole topic. જેને આ બધું મેથ્સ નો સમજવું હોય કઈ વાંધો નહીં, પણ પ્લીઝ તમે મેથ્સ નો રાખતા, right? Okay, because you are going to have to study this. For anyone who wants to skip the mathematics, here is the final important line for us. Displacement is the addition, sigma ખબર પડે ને, addition of the small displacements that we have found, right, which is actually addition of area of small rectangles. Agreed? Okay, but this area of small rectangles is nothing but addition of VDT. I hope you realize that, because dx was equal to VDT. Okay, right? And that is why, and this whole line is the reason why displacement is the area between VT graph and x-axis, right? I hope you have understood which area we were talking about when we were drawing these rectangles, right? This is clearly the area between the graph and the x-axis, right? So I hope you have understood that, right? Okay, those who have queries will please contact me personally. All right, I think that would be better, right? I've already repeated it twice. So this is the final thing, right? Okay, we divided it into multiple rectangles which are very small, and then we took area of all that and we added sigma, that is addition, right? Okay, and that addition is nothing but addition of vdt, right? Okay, so this is what you could have. Now we will see what is integration symbol. Okay, so finally we are on to maths now. Okay, I've explained the physics that I wanted to. Now we are talking about integration. First of all, symbol, right? Symbol of integration is like this. Okay, fine. So this means you are taking everything, you know, this is what it means. All right, this is the symbol of integration. Okay, right? So that's one thing, right? Now just like we used to do differentiation and there were rules, here also there are similar rules, right? But all rules are, you cannot do it on keyboard, you just write int. Okay, I mean you can, there is some code for that, right? There is some uh, combination that you'll have to press, but you don't have to worry about that, right? You don't have to type it ever. So anyways, so this is its symbol, right? Okay, now let's write rules. Okay, rules of integration. See, just like there were rules of differentiation, there are rules of integration, and many rules are similar. Let me tell you that many rules are similar, so it's going to be easy if you remember all those, right? So rule number one. See, this is how you write a word before we start. If you realize, writing like this is nonsense in differentiation. Okay, I'm talking about differentiation over here. Writing like this is nonsense. You should write upon dx, correct? Or something, right? I hope you get what I'm saying. This, if you say that this is equal to nx raised to n minus 1, then I'm going to obviously remove you from the meeting, correct? This is wrong. This is how you should write it. Is that clear? Okay, so just like that, when you are doing integration, listen to this carefully. When you are doing integration, there has to be some infinite symbol like this over here, that like dx. Okay, so for example, writing like this is nonsense. Okay, this is nonsense. This doesn't mean anything. This is okay. Clear? Right? Similarly, this is also okay, possible, but because this is some infinite symbol, right? So integration is never going to be there without infinite symbol. Let me tell you why again. If you realize, that's what we have had here. Look at this. This is sigma. Sigma means addition. Addition of v dt. So this addition of v dt, addition is integration. I hope you remember that, right? So this is integration of v dt, as you can clearly see, right? So whenever there is integration, there has to be something like this, dx, dt, dv, something like that over here, right? Okay, only this is wrong. It won't give you anything except 0 marks, right? આ example તો કરવા જ પડશે સાહેબ. Okay, so first of all, this rule, integration x raised to n dx is equal to x raised to n plus 1 upon n plus 1. Okay, right? Again, this is not valid. You can use this only if n is not equal to minus 1. So this is rule number 1. If you realize, this is the rule that we have in differentiation also, but this is in opposite way. So let me give you an example now. Have a look. Okay, here's your example, people. Watch it carefully. All right, compare this with the rule. What is n. What is n here? It is, of course, what's n? People, what's n? Yes, very good. Yes, well done, Ananya. N is 3. I hope everyone realizes that. N is 3, right? So this answer will be x raised to 4 upon 4. Is this clear? This answer will be x raised to 4 upon 4. Okay? All right. Okay. So what I was telling you is that there's something very nice that you could remember. That integration is actually the exact opposite process. Integration is actually the exact opposite process of differentiation, right? Okay, it is exact opposite process of differentiation. Let me show you why. કરો તો આ આવડે ને કરો આવડવું જોયો આટલી બધું ડિફરન્સિએશન પ્રેક્ટિસ કરાવ્યું છે. Come on everyone. Very good. Divya, Jay, it's wrong. Divya, it's right. Cancel the 4. Ankita, it's right. Well done, Ananya. Yes, Dhruvi. Correct. Joy. Yes, sir. I hope all of you do remember this, that you can take 1 by 4 outside because it's a constant. Kick the constant out rule, and now this is 4x cube upon 4. Right? This is 4x cube upon 4. So 4 is cancelled and you get x cube. See this. See, I'm writing a sentence here, right? Integration of x cube gives us x raised to 4 by 4, correct? And differentiation of x raised to 4 by 4 gives us x cube, isn't it? So do you agree? Do you agree with this sentence now? All right. Just like square and square root are opposite processes, or addition and subtraction are opposite processes, just like that integration and differentiation are also opposite processes. All right, fine. So that actually makes it quite easy, right? It will it will help us in many situations, right? Okay, let's try another example, see if you can do it very well. Okay, try this. What do you get? Come on, hurry up, tell me the answer, everyone. Tell me the answer quickly. Final answer, hurry up. Yes, it is x raised to 6 by 6, right? Yes, it is x raised to 6 by 6. All right, very good, fine. Okay, so for the time being, this is rule 1. I hope rule 1 is clear. Again, do not use it for n equal to minus 1. All right, do not use it for n equal to minus 1. Okay, let's go to rule number 2. Your favorite rule. Yes, Ria, do you have a doubt? Your favorite rule, same as it was in differentiation. Okay, okay, Ria, no problem. Kick the constant out. So all right, this is absolutely clear to all of you. So let's take an example. Okay, so suppose we are doing integration of 3t square dt. So dt means t is variable, this is changing, right? So t is changing, but 3 is a constant. All right, 3 is a constant, so kick the constant out. Okay, and then follow usual procedure. Clear? Okay. Very good. You all are learning fast. This is same as differentiation rule, isn't it? 60 can be Kathan. Why is it 60? Okay. Next rule. I hope everyone is making a list of the rules. Number 3. Addition subtraction rule. Chalo. This is so easy. So I'm okay, fine. Let me write the rule first. I thought we would be able to do it without that. See, you should write dx and integration sign 2 times, okay? Like this. I don't think I have to say a word of explanation over here, right? Okay, the same will hold for subtraction also. Okay, so now let's check this. Let's check whether you have understood how to apply this rule. Okay, so suppose someone would give me integration of t cube minus t squared plus um, let's say t raised to 4. Okay, simple. Or let's make it 2t raised to 4. Yeah, then what would be this? Can you try it, everyone? Can you try it? Yes, Sahil, do you have a question? So first step, everyone, first step will be as follows. You write it like this. Separate everything. Okay, I'm just writing the first step so you can get started. Sahil, do you have a question? If you have a question, you could type it. I'm giving you 1 minute. After 1 minute, I will write the answer. Okay, then you tally whether yours is right or not. Very good, Kavya. Yes, Divya. Yeah, yes, that's right, Divya. Okay, I'm writing the answer now, and the what did you not understand, Sahil? You just have to separate the terms, right? That's it. Okay, this is your final answer. Again, 2 is a spectator because 2 is constant, it plays no role. You can simply, you can just write it outside. Okay, Sahil, you just have to do it term wise. That's it. Okay, right? That's all. Separate it term wise. Okay, now, so that's the addition subtraction rule. All right, the same thing holds even if this was subtraction, so you could write either plus or minus. Yeah. Okay, right. Now next rule, number 4. Okay, number 4, it is about integration of only dx, right? Only dx, right? There is nothing else, right? There is no x in front of it, there is nothing else, only dx. Then this is equal to x. this is equal to x, right? Okay, here we can't give an example, right? We have to give a proof. So why is this true? Let me explain. Or I think I should give you a minute to think about it. Come on, everyone, 1 minute to think. Why is this true? 1 minute to think. Why is this true? I'll give you a hint. Use all rules taught so far. Okay, this is your hint. You can use all the rules taught so far and you can prove it. Very good, Ami. D is constant. Ayushi, no way. This is not D. This is dx together, right? You can't separate these two. X is not constant. See, everyone, if x was constant, this would mean nonsense. Why? I'll tell you. Because if x is constant, dx means small change in constant, right? Dx means small change in constant, isn't it? If you are saying x is constant, then this is ridiculous. How can something that is constant have a small change, right? Very good, Divya, you have got it right. Rahul, x is position. That has no relation or nothing to do with this. This is maths. Frankly, this page is maths. It's not physics, right? Okay. Yes, Kavya, what is it? No, Vedant, your answer is wrong. They were, no, what you have written is not valid. Okay, everyone, this is how it can be proven. Have a look. This is how it can be proven. So first of all, I'm sure all of you will realize that 1 into dx is dx, right? I don't think anyone has any problem with that, right? 1 into dx is dx. But 1 means x raised to 0, isn't it? I hope you know that some some number raised to 0 is 1, right? So now if I use rule 1, then this is going to become clear, and hence this is x raised to 1 upon 1 means x. So finally, here's your proof. All right. So this is the rule, and here is the proof. Clear? So just like that, you should not forget that integration dt will be t, integration dv will be v. Clear? Okay. All right. So that's it for this rule. Okay. Right. Now let me just have a look. Yeah, we still have one more thing. Yeah. Okay, let's go to the thing number 5. Right. Rule 5. So this rule 5 is about putting values. All right. So you write it as I'm writing. Okay. Putting values, upper limit and lower limit. All right. So that's the title I'm giving it to this rule. Okay. So let's see what this is. To give you an example, before we even start, I'm going to explain why we need to understand this rule. Okay. Have a look at this. So here we were talking about an VT graph and we wanted to find displacement. So we were finding area under the graph, right? So of course, like I said, that this area between the VT graph and x-axis is actually found by integration of VDT, right? But in practice, listen to this carefully. In practice, what happens is as follows. Suppose that this is some VT graph. All right, suppose this is some VT graph. Any shape, once again, no problem, whatever shape. And let's say here is time t equal to 1 second, and here is time t equal to 3 seconds. And I want to find out what's the displacement of this object. I want to find out what's the displacement of this object from t equal to 1 second to t equal to 3 seconds. Right? Arkan, I'm shouting over here, right? This is actually the highest or the loudest possible, right? There might be some network problem. Anyways, so I'm saying that if we want to find what's the displacement of the object from t equal to 1 second to t equal to 3 seconds. All right? Okay, fine. Right. So then do you realize that we should only be finding an area, we should only be finding an area from here to here, right? We should not go beyond this. That is, this area is not useful and this area is also not useful. Agreed? We should only be finding an area between 1 second to 3 seconds, right? Agreed? So like I mentioned earlier, we can find this area by splitting this into thousands of such tiny rectangles. All right? Okay. So basically, I have to add or integrate, right? Addition of such small things is called integration, right? I hope all of you have understood this. What I have done is, I'm saying that we have to add, agreed. We have to add sigma, addition, right? Addition of what? This small area. What's that? VDT, right? That small area is VDT. So VDT, 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 like that, we have to add all those VDTs, right? But that addition of such small areas or small things is called integration. So we write integration VDT. But here we have to take a boundary. Boundary means limit. You should not cross that. You should not go here. You should not go here. So we have to remain between time equal to 1 second and time equal to 3 seconds. Did you understand what I indicated here? Right? Do you understand why I'm writing 1 and 3 over here? We have to only find that area which falls between 1 second and 3 seconds, because I want to find displacement from 1 second to 3 seconds. Clear? I'm waiting for your response, everyone. Have you understood why I wrote 1 and 3? So, looks like most of you have got it. Of course, it will be better when I'll give you one or two examples, all right? So, please don't worry about it. It will be even better gradually. Right. So, let's go to the thing we were talking about. So, oh, sorry. Yeah. So, I was telling you that whenever we do integration, right? Typically in physics, when we do integration, we always have some lower limit and upper limit. All right, we always have some lower limit and upper limit, right? Okay, and then we have some integration, right? And what we have is as follows. See, whenever you want to do integration, so let me give you an example. Whenever you want to do integration, suppose of x cube dx, and if you write 2 here and if you write 4 here, what this means is, the initial value means starting value, right, of x is 2. Starting value of x is 2, right? and final value or upper limit, final value is called upper limit of x is 4. Understood? Final value of x is 4. Okay, right? So listen to this very carefully. So when you do this, this is how it operates. First step, you ignore these upper and lower limits. All right, you just ignore the upper and lower limits. All right, and just do integration by following rules that I have taught you so far. Is this clear so far? Using rule 1, using rule 1, is that clear? Right? Okay, so far we have not used these limits, lower limit, ll for lower limit, ul for upper limit, right? Now over the whole thing you write a square bracket like this, compulsory square bracket. અહીંયા કોઈ designer brackets નહીં બનાવે આવા કે તમારા special triangle shape ના કોઈ પણ. Okay, everyone, compulsory square brackets only. Clear? And on the right hand side over here you write 2 and you write 4. આ raised to 4 નથી હો, this is not raised to 4. Okay, what this means is, what this means is that the upper limit is 4 and lower limit is 2. Okay, clear? This is not raised to, everyone. So then what to do? Like we have always been doing, we will do final value minus initial value. What I mean to say is, listen to this carefully. First we put x equal to 4 here in this whole thing. All right, did you understand this? First we put x equal to 4 in this whole thing. Is that clear? Because this is final, right, or upper limit. All right, we are talking about upper limit. Then we put a minus sign, compulsorily minus sign, because changes are always found by final minus initial, right? Changes are always found by final minus initial. So upper minus, now we will put lower limit. What is the lower limit? Lower limit is x equal to 2. I hope you understand that, right? Lower limit is x equal to 2. So I should write 2 raised to 4 upon 4. I'm actually concerned about this. Is this clear? Okay, okay, all right. Yes, I will repeat, don't worry. This is a very tricky concept. Yes, very good, Ananya, you have got it perfect, right? Sahil, નથી સમજાતું નહીં ચાલે. You will have to specify what you don't understand, right? Okay, so let's take another example that will make it little bit clear. Suppose I want to do integration of 1 to 3 t dt. Suppose I want to do integration of 1 to 3 t dt. That means t equal to 1 is lower limit and t equal to 3 is upper limit. Again, lower limit means like initial, all right, and upper limit is like final. Is that okay? So first of all, you just ignore the limits, ignore the values, okay, and just do integration. So what is integration of t dt? Follow the rules. What is integration of t dt? It will be t square by 2, right? I don't think anyone has any problem with that. Okay, integration of t dt is t square by 2, right? Yes or no, everyone? Is this clear? Okay, very good. Yes, Rehan Khan. t means t raised to 1. I hope everyone realizes that. So follow the rule 1. Okay, so you'll get t raised to 1 plus 1 upon 1 plus 1. All right. So t raised to 2 upon 2. Okay, t square upon 2. Now, like I said, compulsorily put square brackets. Okay, no problem. Right, and then you write 1 and 3. Okay, why 1 and 3? Lower limit and upper limit. So now what to do? First of all, you put upper limit value. All right, so instead of t you write 3. See, you don't have to write this thing that I'm circling. You just have to write it as you are writing some mathematical equation. Okay, right, now we put upper limit, so t equal to 3, so this will become 3 square by 2. Clear? Okay, 3 square by 2. Right, then you compulsorily put a minus sign. Right, okay, and then you put lower limit. All right, then you put lower limit, which is t equal to 1. Okay, so this would become 1 square by 2. Got it? So now what we have is 9 by 2 minus 1 by 2, so 4 is your final answer. This is how you finish it. Okay, right, so I hope things are clear now. Right, again, ખરેખર easy છે. Right, it's not tough at all. Right, એક વખત પ્રોસિજર સમજાઈ જાય ને તો પછી આવડી જાય. કઈ કોમ્પ્લિકેટેડ નથી કરવાનું. રિમેમ્બર, યુ જસ્ટ હેવ ટુ ડુ ધીસ. After integration you have to put upper limit value. Okay, then you put a minus sign, and then you put lower limit value, and that's how you get your answer. Right, okay. Right, so this is how you put values. Clear? Is putting values clear? Okay, why don't you try one more question, and then we will stop. Okay, and I might also give you some questions to practice like this. Okay, try one with me, then the others for homework. Okay, so here, try this. Suppose you want to find out what is 2t minus t cube, 2t minus t cube dt. You have to write something here. Okay, and typically it's to be dt if this is t, from, let's say, from 1 to 2. Okay, from 1 to 2. Find it, come on. Follow all the rules. Limit, the putting values will come at last. All right, first you have to do integration. Follow all the rules and then put values. Come on, people. I want all of you to, no problem, Preet. Upper limit and lower limit can actually be anything. All right, anything. Don't worry. Right, upper, and it is also not necessary that upper limit should be greater than lower limit. This is also not necessary. Understood? Okay, it could be anything. Upper limit, lower limit can actually be any kind of numbers or anything. Right, but don't forget one thing, that upper limit indicates final and lower limit indicates initial. That is something which you should not forget. All right, okay. Right, so step, come on, tell me the first step. Tell me what you get after doing integration without putting values. Okay, tell me what you get after doing integration. Come on people. જો ટાઈમ ના પાકા લોકો જવા માંડ્યા, 9 વાગ્યા તો. I have to say, you all are very punctual. You are much more punctual than me. Okay, t t square minus t raised to 4 by 4. This is what you will get after integration. Is that okay? Vedant, I don't know the answer actually. I'll have to do it. Only then I'll know the answer. Right? I hope this step is clear. Right? You have to get this right. This is the first thing. Without this, you will not get the correct answer. All right? Okay, Dikshita, you're getting -3. Interesting. And now, how should we write it? We should write it in square brackets, compulsory. All right? Like this. Put 1 here, put 2 here, and then continue. Right? So what to do first? What to do? See, you can do this separately also. What do I mean? Because this is addition subtraction, ultimately first you are going to do it like this. I hope that makes sense to you, right? So you can do this separately also. It will be right. What I mean to say is like this. Okay, this is also fine. What I wrote earlier was correct. This is also correct. Okay, is this okay, everyone? Right. Now let's put values. So first of all, we have to put 2. T equal to 2, right? So 2 square. Then compulsorily put a minus sign. Then 1 square. Okay. Minus. Now this is this minus, all right? Okay, this minus is this one. Final, that is upper limit 2. So 2 raised to 4 by 4 minus 1 raised to 4 by 4. All right. Okay, this is for upper limit, this is for lower limit. This is for upper limit, this is for lower limit. All right. So this is now going to be 4 minus 1, 3 minus. And here, this is going to be 15 by 4. Right? This is going to be 15 by 4. 0 no આવે જયરાજ. Right? So final answer of everything combined is, take LCM, 12 minus 15 by 4. So that is minus 3 by 4 is the final answer. All right? Minus 3 by 4. Okay. All right then. So that's it for today's lecture, right? I will send you some, a few questions regarding such integration practice. Okay, so I hope you could do it, right? Goodbye, everyone. Yes, I will definitely send the important points to everyone. Okay, don't don't worry about that. Today we have important points, so I have to send it to you, right?